Hello and hi. In today's video, I'm going to look at matrix multiplication, specifically 3 ways to remember matrix multiplication. The first way is sort of a straw man. No one really teaches it this way because it's there's nothing behind it, but let's go with a simple example. So we'll go with a 2 by 2 multiplying with a 2 by 2 matrix. We'll write some general entries. And this first method is the most obvious sort of by hand method. So what we do is, the way this works is we take the product A times E and then entry B times G and add them together. Then we go down and we have C times E plus D times G. Okay, and then we'll sort of complete it. We'll go across to the next column and we'll have A times F plus B times H. And then for the last entry, we'll have C times F plus D times H. Okay, so no one thinks about matrix multiplication this way, and no one explains it this way, because there's no point. At the very least, what we should do is we should note the sort of geometric shape of this. So matrices have rows and columns. Each of these going across is a row. So AB is the first row, CD is the second row. And then each of these going up and down vertically is a column. So EG is the first column of this second matrix. FH is the second column of the second matrix. So the other way to think about this is to think that the rows are acting with the columns. So if I look at this, I say, what is the definition of this? I'm taking this bit, and I'm sort of morphing them together. So we could say something like, okay, this is the first row, first column of our result. We get it by multiplying the first row with the first column. This is the second row, first column. We get it by taking the second row with the first column. So the second way of looking at matrix multiplication is to think about the first matrix as a concatenation of like row 1 and row 2, and the second matrix is a concatenation of column 1, column 2. Okay, so as we can see in this case, row 1 would be the vector AB, row 2 would be the vector CD, and so on. So then what we can do is we can say, okay, well, what do we call it when we pick up the elements of a vector and multiply them element-wise with another vector and add the results together? Well, that's a dot product. So we can say, okay, the first row, first column here would be the dot product of the first row of the first vector with the first column of the second vector, and so on. So then we have second row, first column, and then onwards and onwards. First row, second column, and then second column, second row, second column. Okay, so that's another way to think about matrix multiplication, is selective dot products. By the way, let's say that we have, just in general, a vector A and a vector B. The dot product is actually, can also be written as taking A transpose and multiplying it with B. Because, have a look at that. Transpose A, so it's A, B, C. Leave B there. And then if we multiply this element-wise, we get AD plus BE plus CF, and that's the dot product. Anyway, So the third way that I want to look at matrix multiplication is as transformations. When I was learning this for the first time, this is how I really remembered matrix multiplication. Let's say we have a general xy point and we want to hit that point with a transformation. Well, the most general transformation will use all of the information available. So when a point is hit with a transformation, it produces what's called an image, which is really the result of that input after transforming it. So the most completely general transformation would be to take something times the old x coordinate plus something times the old y coordinate and set that as the new x coordinate. And then to take another potentially different coefficient times the old x coordinate and another potentially different coefficient of the old y coordinate, and that together makes the new y coordinate. So yeah, we're using all the information that we have, x and y, to make new x and y coordinates. And actually, a lot of different classes of transformations are described by special cases of these a, b, c, d coefficients. Well, how would it work if we had multiple points? Well, it would work exactly the same way. We would have a, b, c, d, and then let's say we have 3 points. We have x1, y1, x2, y2, oops, x3, y3. Well, then we would just go through the same formula. I won't write it out because it's just a little bulky, but as you can see, it would be using the same ABCD filter. We would have this column would be some point, this column would be the second point, and this column would be the third point. So yeah, it's also useful to start thinking about what matrices do. Okay, there's sort of, I think of it as there's sort of two important uses for matrices. One is simply to store data, like this second matrix here is a set of points. Each column is a point. And the second use of a matrix is to describe a mapping or a transformation, and that's what this first matrix is doing. Just a little side note. Yeah, I'll go into this and then that'll be it. So a little side note on matrix transformations as well is dimensionality is really important. So if I have a matrix A, which is, let's go, its dimensions are A rows and B columns, and I multiply it with another matrix, what needs to happen is the number of rows in B has to match the number of columns in A. I call this inner dimensions. The inner dimensions have to match. Okay, so I can look at this visually and see that yes, the inner dimensions match, and then the result, whatever that product is, the result has the outer dimensions. So let's say, for instance, I take, let's go 2 by 3, so I'll go 2 rows and 3 columns, and I multiply it by a, we'll go 3 by 1. Well, if we think about this in terms of transformation, so this column is a point, is a 3D vector, x, y, z, and this first row is the filter, the linear combination coefficients which describe the x coordinate of the output. So we need 3 elements here because we're throwing in 3 coordinates, right? I'll say that again. Because we're throwing in 3 coordinates, they need to be consumed by 3 columns, 3 coefficients. So anyway, we transform the first row with the first column, and that produces some entry, which we put there. And then we consume that data again and transform it through the second row, and that we get a result there. So as you can see, this is a 2 by 3 multiplying with a 3 by 1 matrix, and the result has dimensions 2 by 1. Okay. So over the next few videos in this series, we're going to be looking at other examples of matrix multiplication, other uses of it, but this is just, in my experience, one of the major thresholds people have to pass through is sort of understanding the algorithm, getting a feeling behind it before we even do anything. Anyway, hope that helped, and I will see you in the next one. Bye.